Hello and welcome. My name is Micah Silverman, and today I'm going to be talking to you about blasting browser security with extensions. Before we get into it, just a little bit about me. I am a senior security hacker on Okta's developer advocacy team. You can tweet me at @afitnerd, and you can tweet our whole team at OktaDev. I got to co-author this book, Mastering Enterprise Java Beans, just in time for that technology to be irrelevant, but it's something I'm proud of. I contribute to open source projects on a regular basis. Pictured here is the Java JSON Web Token project, and it's the most starred JWT project on GitHub. And then I'm a regular contributor to Okta's developer blog, and this particular example is a 3-part primer on OpenID Connect. What we're going to be focusing on today is the broad authority that browser extensions can have over your browser, and hopefully, I have a little surprise at the end, we'll be publishing an actual browser extension to the Google Chrome Web Store and the Firefox Add-ons Store, and we'll see if they actually make it through whatever review process they have. What is a browser extension? It's a small software module for customizing a web browser, according to Wikipedia, but it can have all kinds of different levels of access to your browser, to pages in your browser, to data stored within your browser. Pictured here are just a few that I have in mind, well, maybe more than a few, but 1Password, the implicit flow detector, privacy.com, eyedropper, and a bunch of others. I use these browser extensions pretty regularly, and with the exception of the implicit flow detector, which I wrote, I don't really know or remember what access these browser extensions have. We're going to look at the different types of access and the kind of authority that it gives when you ask for those permissions. Now, a browser extension is made up of different components. Not all of them are required or necessary, but a file called manifest.json describes what the functionality of your browser extension is going to include. This can be background scripts. These are things that alter headers and URLs and work in the background. And we're going to see in a little while that you can do everything from changing URLs in flight to adding in additional headers that weren't originally part of the request. There's also pop-up scripts. Those are the user interface for your browser extension. Some browser extensions have a user interface and some don't, but a pop-up script is literally what will pop up when you click the icon for that browser extension. And then you can also have content altering scripts. We're going to see an example where it replaces all of the E's on a page with E's that have an umlaut over them. So you can replace that content in flight and alter the page that was received. And if you don't know what your browser extensions are doing, you might not even realize that a browser extension has altered the page on your behalf. Now, continuing with the anatomy of a browser extension, these are the different sections of the manifest.json file. And if this isn't super clear, if it's small on your screen, we're going to get into it in just a little while, so don't worry. But we have a section for background scripts, so that describes the JavaScript that's going to function as our background scripts. We have a section for content scripts. Those are scripts that are going to manipulate or alter content. And then we have pop-up scripts, and that's the user interface for the browser extension itself. Importantly, we have a list of permissions that the browser extension is requesting access to, and you can see in my example here, the browser extension has very broad authority. So first of all, I'm going to match every kind of URL that there is to match. So that's what all the */** business is there. Then web request and web request blocking, those are very powerful permissions. That's what allows me to manipulate the URL, and importantly, to manipulate the URL in a blocking way. That is, I can intercept a URL that you've requested or that the page has requested, alter it, and then let it continue. I'm also asking for permission to the tabs of your browser and for the storage system. Now, you may be familiar with local storage for browser applications. If you've written JavaScript browser applications, storage in this context is storage specifically for the browser extension area. So it's a separate area, but you still need the permission to be able to write to that storage area. Now, a little bit of background about browser extensions. Both Google Chrome and Mozilla Firefox are pretty much the leaders in browser extension technology. They were looking at accomplishing similar things. They kind of leapfrogged back and forth over each other, adding features and functionality. I don't know enough about Safari or Internet Explorer to say how their extensions are, how they work, what the technology is, but Chrome and Firefox are kind of the main ones and the ones we'll be focusing on. But it used to be that they had different ways to access the browser extension features, and for the most part they had very similar calls, but in Chrome in your code you would call all of the methods and functions with chrome.something, and in Firefox you would call browser.something. And there isn't a one-to-one match. It isn't 100% overlap, but it's pretty close. Both Chrome and Firefox have this web request, for instance. Now, as we went on in the history of browser extensions, Mozilla Firefox did us a solid and came up with browser-polyfill.js. A polyfill is a piece of code used to provide modern functionality on older browsers that do not natively support it. Now, Chrome is not an older browser, but what the polyfill did was it made it so that whether you were on Chrome or Firefox, you could use all the same code, and this now enables us to write our code once and create a browser extension that will work both in Firefox and Chrome without having to write different code. So now, whether it's Chrome or Firefox, you use browser.webRequest, and the only downside is that you have to make sure that browser polyfill is in all the sections of your browser extension code, like the background, the pop-up, and potentially the content scripts. web-ext for the win. This is a project from Mozilla that leverages polyfill, among other things, and it makes it so that it's easy to develop, test, build, and deploy browser extensions, both for Firefox and for Google Chrome. Let's take a little walk through the browser extension. We're just going to look at a demo first, and then we're going to dig into the code for this and look at the kind of authority that it has. And a little later on, we're going to submit this to the browser extension stores for Firefox and for Google and see whether or not they get accepted or rejected. All right, let's take a look at this in action. On the left, I have Firefox. On the right, I have Google Chrome. On the bottom of each of these, I have what will look familiar to you if you're familiar with using the developer tools in either Chrome or Firefox, but in this case, it's the developer tools console for the browser extension itself. It's not the regular page console. Now, to get here, I used web-ext, and I can use this command, web-ext run Firefox desktop and web-ext run Chromium. And now I can make sure that what it does is it sets everything up to be able to run your extension in the browser, and it's got a live reload function. So this is a great way to develop. It's similar to developing a modern JavaScript app like an Angular app or a Vue.js app, where you have this runtime environment that will auto update. So I can make changes to the code and I can see it in real time, and the only reason I would need to restart web-ext would be if I were to change the manifest in any way. Alright, first thing I'm going to do in each of the browsers is I'm going to go to a website. I'm going to go to my own website, and we're going to take a look at just some of the features of what this browser extension does. So both in Chrome and Firefox, I'm going to my personal blog website. Now when I click on the pop-up here, what it does is it shows different random kitty GIFs. That's ostensibly the main feature and the main functionality of this browser extension. Now it also has a couple of hidden features, or not so hidden features, and I've purposely set it up that you can control these features through this pop-up. And primarily we just have these two checkboxes. One is replace ease and the other is replace images. And if I click replace ease, you'll notice that in all the links on the page, it's replaced the ease with an umlaut over them. And if I click on replace images, it reloads the page and replaces all of the images with kitty cat pictures. All right, we're going to be looking at the code for this in more detail. So that's Firefox. Let's make sure the same thing is happening in Google Chrome. Same thing, so I can see that the ease with umlauts have been set up, and I can scroll around and see that all the images are now kitty cats. Now, a couple of other things. These are sticky settings, and one thing that's worthwhile knowing is that every time you click on the browser extension icon here, it's reloading this pop-up page. So we need some way to save state here. We need some way to know that these were checked or not checked, because it doesn't naturally save state. Every time I click this, it reloads this pop-up window. Now that makes it super easy to show a different kitty cat GIF, but it makes it a little more challenging to save these checkbox states. The other thing to note is that this is sticky. That is, if I browse to any website now, like let's say okta.com, you'll notice that right away we have kitty cat pictures and we have umlauts over ease. So this is a sticky setting, and it's now going to apply to all the websites that I go to. Now, part of the motivation in making these check marks is because I want to publish this on the web store, and I wanted to be able to demonstrate broad authority in the browser without having it be truly malicious. So if you uncheck the checkboxes, everything reverts back to the way that it's supposed to be, but you should know that I could have just made that the default behavior and not have it be driven by checkboxes. All right, there's one additional feature here that I want to show you, and to do that, I want to look at the regular browser console here, the regular developer tools console. So this is for the main page, not for the extension. I want to focus on the network tab, and I'm going to go ahead and reload this page. And what I want to point out to you is that the request headers have a header that ordinarily would not be part of the request. So the browser extension has injected a new header called x_nothing with the value to see here. So this is the kinds of things that you can do when you have a browser extension that has very broad authority. One other thing I want to show is if we go back to here, you'll notice that I'm outputting a version of the URL that I'm going to with an altered URL. So it tacked on injected parameter on the end of this URL. Now, I didn't actually alter the URL because, again, I don't want this to be fully malicious. I want it to be able to be listed on, or I want to see if it can be listed on the add-on stores without actually doing anything malicious. You may, if you've ever played D&D, you may have guessed that I'm a chaotic neutral. So I like to mess with people, but I don't want to actually do anything malicious or hurtful. So I'm outputting here that the URL has been altered or could have been altered without actually altering it. So if I go to, say, octa.com again, here we see that it altered the octa.com URL, and that it could have tacked that on to the actual URL, but it didn't. So that's all the features of the browser extension. It can replace ease. It can replace images. We have a pop-up where you can control those features and the checkboxes are sticky. It injects headers, and we're going to look at how all that is managed next in the code. All right, where we're going to start is with the manifest.json file. And it has some setup like the manifest version we're using, the name, the version of the extension itself, a description, homepage, and icons. Then we get into the primary sections here. So we have permissions like I showed before, and I'm requesting very powerful permissions here. We'll see if it makes it past the browser stores a little later. Then I have a background script section, and if you notice, I have polyfill and I have background.js. So I'm including that polyfill, which is the engine, if you will, that makes this multi-platform. It makes it work in both Firefox and Google Chrome. I then have a content script section, and the matches drives what type of content will be replaced. So I'm saying everything, any content should be replaced, or rather this script should be used for any content. And this also uses Browser-Polyfill, giving me that platform independence. This references a beautify.js bit of code. And then finally we have some metadata here to specify the icons that are going to be used in the browser itself and our default pop-up. So here's where we're defining the pop-up for the extension. Now, if an extension doesn't have a pop-up, it just wouldn't have this default pop-up line here. It would still have the different icons that go with it because that shows up in that part of the browser. But this says we are going to have a pop-up, and it's called pop-up index.html. So why don't we take a look? Why don't we start at pop-up and see what's happening there? Now this is actually a very straightforward standard HTML file, and one of the things I should take a step back that I endeavored to do here is I'm explicitly not using technologies like Webpack because I wanted this to be very vanilla JavaScript to keep things simple. But when you build a browser extension, it's just JavaScript, so you can use tools like Webpack to be able to organize things into modules and make things really tiny. I kept everything very simple. So the most important thing that's going on here from the perspective of what this browser extension is supposed to be doing is this image. And it's simply calling the cat API and telling it to give me a GIF type of image to display on the page here. So that's what gives me a different cat image every time I click the icon. And I don't need any fancy logic to refresh that cat image because, as I said before, when you click the icon, the pop-up code is always loaded newly. So that's just part of the way browser extensions work. Now, on the one hand, that's super convenient for being able to show random GIFs. On the other hand, it's a little more challenging to maintain state here. If I didn't do some sort of programmatic maintaining of the state, then even if we had checked these checkboxes, when we clicked on the cat picture the next time, they would be unchecked. There we go, back to normal. All right, so that's the GIF image. That's a one-liner. Then we have our checkboxes, and they each have ID. One is ES for ease, and one is IMGS for images. Then we have our polyfill. So you can see one of the downsides here is that polyfill shows up a lot, and it's kind of on you to remember to include it, but it's worth that little bit of extra effort because it makes it so that we have the exact same code base, whether it's Chrome or Firefox. Finally, this calls in a support JS, and part of the security, I'm saying that in air quotes, of the browser extension frameworks is that you can't have inline scripts. There's a content policy that blocks that, so you have to reference script files. So let's go take a look at that support.js file and see what's happening there. So this is all just about rendering those elements, the GIF and our two checkboxes. Let's take a look at support.js, and we're going to jump down to the bottom here. I'll make this a little bit bigger. And now we have some interesting things going on here. I'm actually going to take a look. All right, so browser, that's our key to accessing everything that has to do with the browser. And this is going to work in both Chrome and Firefox thanks to Polyfill. And the first thing I'm doing is using the local storage area for browser extensions to get this key called Pretty Kitty Settings. Now this returns a promise, so we then have a then section, and we get that item that gets retrieved from the local storage area. And this can be a little bit confusing here. We don't get the Pretty Kitty Settings item directly. It's an object that gets returned, and we then have to reference the Pretty Kitty Settings out of it. So it's a little bit of duplicate looking code here. But now we have the actual settings. And now this is going to ensure that those checkboxes for ease and images are checked according to the values found in the settings. So we're saving the checkbox state in settings, and this is either going to be true or false for each of those, and that's going to then drive whether the checkbox is checked or not every time we click the pop-up. So because it saves that state, every time we click the pop-up, it's executing that support.js, which restores the state here based on what it found in local storage. So even though pop-up keeps getting reloaded every single time, we have our state properly represented using very simple and straightforward vanilla JavaScript. Let's take a look at what else is happening here in support.js. So the first thing we looked at is initializing the state of the checkboxes based on what's found in local storage. We also have a couple of management functions here, listener functions, and those are going to manage what happens when these checkboxes in the pop-up are clicked. So again, vanilla JavaScript here, we're getting an element by its ID. We have ease and we have images. And when those checkboxes are clicked, we're calling an update function, update settings function, and passing in a particular value here. In one case, it's replace ease. In the other case, it's replace images, but we can reuse this update settings function. Continuing to scroll up, our update settings function takes an item name. And one thing you'll notice here is that all of this is async. Everything that happens, all of the function calls off of our browser handle are all async. So we're going to have thens and catches. I've endeavored to keep everything simple, so I left off the catches. But we're going to get the Pretty Kitty settings just like we did before, and then our promise handler then function here is going to get that item. We're going to isolate the Pretty Kitty settings. So again, it looks like a little bit of double work here, but there is a method to the madness. And then here's really the main event here, this line 5. And all we're saying, this update variable now holds a JavaScript object that has two keys in it, basically. It's got replace ES, or replace ES, and replace images. And so it's saying update is now going to be the opposite of what it was. So if it was true, it's now going to be false. If it was false, it's now going to be true. Right? That's what happens when we click on these checkboxes. And then the last bit here is pretty critical. We're now going to save back to local storage at this key, pretty kitty settings, this changed update object. So we get the update object. It's got two keys, replace ES and replace images. We're altering one of those here depending on which checkbox you just clicked on, and then we're saving that back to local storage. Now that also returns a promise. It doesn't take any arguments, so we're just going to resolve that promise and just log out to the console that everything went okay. So support.js really serves two functions, and they all have to do with managing the state of both the visual buttons and the underlying storage. So down here we initialize, every time the pop-up is loaded, we initialize the checkbox states based on what it finds in storage, and then when we click the checkbox, it updates and saves that state. That's everything that support does. So those features combined are what gives us this functionality of saving the state every time that we click here. And now you can see our umlauts are back now that I refresh that. Now you may be wondering what actually changes the umlauts and how that all happens, because all that we're seeing here is kind of state management. And in order to dig into that a little further, we need to take a look at our background.js. Now this is really the main event, but I wanted to start with the pop-up because it's pretty easy to follow what's going on here. So let's look at background.js next, and here we're also going to scroll to the bottom, and the very first thing it does, hopefully this is starting to look like a familiar pattern, is it goes and retrieves this pretty kitty settings out of local storage, and the very first time this browser extension is installed, it's going to find that there is no item pretty kitty settings. And so for the first time it's going to set those values and save those values, and this is the object that it sets. There's a key, pretty kitty settings, and both replace ES and replace images are false initially, and then just like before, we resolve that call to set, we resolve that promise and just do a little output to the console. I could have just ignored it, I could have just had it empty, but this does a little something to prove that it's finished. So first thing out of the gate when we load up this browser extension is we set up this storage area for browser extensions with this pretty kitty settings key, and we set our replace ES as false. Now here's where some of the magic happens, and that is there's an onChanged listener for this storage area, and I'm gonna alter this on the fly just to make this a little bit more modern. Use a hash rocket. But this listener listens for changes, and when there are changes, it does something. In this case, we're going to query the active tabs, and whatever the current tab is that's local, we're going to reload that tab. So this is a piece of the puzzle as to what happens when we make those changes to storage. So we click a checkbox, it makes a change to the storage area. This in the background is listening for changes to the storage area. And then it's going to reload the page that you're currently looking at in the browser. Now we still haven't looked at the code that actually alters the content. We're going to get there in just a second. In fact, why don't we get there now, and then we'll come back to see what else our background is doing. So we looked at the pop-up. We started to look at the background code. The only thing we've really looked at so far is the initial state and the listener on our storage. Now let's take a look at the main event, which is our content script, and that's called Beautify.js. One of the things you may notice is that the way that this is organized, it keeps all of our code nice and tight and small. And of course, a more complex browser extension would have a lot more code, but it's pretty easy to follow what's going on here with all these separation of concerns. Pop-up is all about the browser extension pop-up that end users would see and managing state through its associated support JavaScript. Our background is all about setting the initial state and listening for changes. And now we're going to look at Beautify, and this is relatively straightforward code. It's going to go and retrieve our pretty kitty settings, and then it's going to check and see if replace ease is true. It's going to iterate over all of the href, all of our anchor tags, and it's going to replace all the ease it finds with an e with an umlaut. Now, I could have replaced all of the text on the page, but I kept it super simple and made this basically turn into a one-liner. And then if our replace images setting is true, it's going to iterate over all of the image tags. So in each case, we're getting elements by tag name. It's going to iterate over those, and this is a tricky little bit of code here that I really like. And that is, it's going to take that image tag element and change the source. And it's going to use this placeKitten API, and placeKitten API takes a width and a height, and it will then find a random kitty picture at that width and height. And so what we're doing is we're replacing the original image with a new image that has the exact same width and height as the original one, so it doesn't mess up the formatting on the page. Now, just so you can see what's going on here, if I say, I'll just go directly there. So placekitten.com, and we'll just give it, say, 640 by 480. It'll go and find me a picture that fits. 800 by 600. Sure, no problem. So we're leveraging this little placeKitten API to replace images on the page, but to still have the page render properly. And we saw that in action, but we can see it again if we go back over to my page. These are all the same size thumbnails that were originally there when I didn't have this selected. So if I turn off images, you can see that the dimensions of these images are exactly the same as the kitten versions. Pretty cool. All right, so we've covered pop-up, we covered a little bit of background, now we've covered our content script, and you can see that this is pretty powerful. Like, we are replacing elements of the page, and if you're not aware of what your browser extension is doing, some pretty sophisticated stuff could be going on here. New buttons on the page. Now, there are really useful browser extensions that use that sort of content replacement for legitimate purposes, but hopefully you can see that it could also be pretty easily used for nefarious purposes. All right, let's swing back to background.js and see what else it's doing behind the scenes. A few more things to review here in background.js, and again, the purpose here is A, to show some of the power that you have with browser extensions, and B, we're getting close to the time that we're going to submit this to the stores, and we'll see if they get accepted or not. All right, so let's take a look at some other things we can do here in our background. We have this web request on before send headers, and this will execute when we're just about to make the request. Now, it takes a function that's going to alter those headers potentially, and then we give it some information, some meta information about what kinds of requests it's going to act on and the permissions that we need. So here I'm specifying a pretty broad range of URLs, anything that starts with an HTTPS, but I am saying the type is mainframe. So you can have your browser extension inspect and alter every single request, the initial page, all of the follow-up requests for images, style sheets, JavaScript. You can mess with all of that. For the purposes of demonstration, the only thing I'm altering here is the mainframe. That is the initial request. In this case, I need to block and I need access to the request headers because I want to alter them before the request is actually made. So this will be blocking. And what we pass to this add listener function, the callback function, gets details, and those details include a list of request headers. And here all I'm doing is taking this array of request headers and pushing a new header, which I showed you before in the browser. The key is called x nothing, the value is called to see here. It then returns the full set of request headers, so I'm just returning back the original request headers plus this new one, and that's what injects that new one into the request that it makes. That's what I showed you in the browser earlier. The last thing here is possibly the most powerful piece of the puzzle, and that is on before request add listener. So just before the request is about to be made, this kicks in, and similarly we need to give it a list of URLs, types. Again, I'm just gonna work on the main frame. In this case, I just need access to blocking because I want this to happen before the actual request. And here you can see I have this commented out code, and what the code would do, actually this, bear with me a second, this doesn't belong here. We're gonna code in real time. What this would do is it would end up making your browser redirect to the original URL, but replaced with and added to with this injected param. And if you're wondering what this business of the replace is, that's just because part of the functionality here, when you check or uncheck, it refreshes the page. And if we didn't get rid of, if you notice I'm replacing it with empty, if we didn't get rid of the injected query string here, it would just keep additively building on that that query string. So all this does is first take the URL and get rid of any previous injected query string parameters, and then it adds this query string parameter. Now this as is not very robust. If the URL already included a query string parameter, this would kind of break things, but hopefully you can see the power, and we're not actually doing this. All I'm doing is console logging it, but you can see that on every main page request, it's outputting what the replaced URL would look like. Okay, so we've taken a full tour now of the background and what it does, and we can see that there's a nice separation of concern. It does our initial setting, and it listens for changes to our storage among these other header and request functions. We also looked at our pop-up and its support JavaScript, which manages the visual state as well as the local storage. And we looked at Beautify, which actually goes about the business of making changes to the live content. Now, before we dive into the Firefox Browser Add-ons and the Google Chrome Web Store, a couple things you should know. You need to set up a profile in each of these, and one of the things that I did in advance is I took an email address that I used that didn't have accounts and registered for both of these stores. You can see it up here. It's micah.silverman@gmail.com. For Google, you have to pay a $5 registration fee. Not the end of the world, not even 100% sure why Google collects that. Maybe they want to make sure that it's a real person that's attached to it. So I did all that in advance, And now we're going to switch over and see if we can publish these add-ons. So I'm going to kill this, and I've made a few changes here. So why don't we go and they're pretty straightforward. Why don't we go and publish those changes? We'll just say bug fixes. Okay, and the next thing I'm going to do is I'm going to get rid of this web-ext artifacts folder. That's where the build goes, just to be safe. It should get overwritten, but just to be safe. You can also see it's part of my git ignore. We don't want to be pushing that up to the GitHub repo. But now I'm just going to say web-ext build. And now in web-ext artifacts, I have Pretty Kitty that's now ready to be published, and it'll work on both Google Chrome and Mozilla Firefox. So let's go and find those. All right, here we go. Oh, this is the GitHub repo. I'll make sure that I have that as a reference at the end. Okay, let's start with the Google Chrome Web Store, and I'm authenticated. I paid my $5. I verified my account. So let's go ahead and create a new item, and we're going to drop the zip file here, and I'll just browse. And that's Pretty Kitty, web artifacts, and there's my zip file. All right, so far so good. Now there are a couple of required fields here, and I may fast forward through some of this. So let's go ahead and save this as a draft. So far so good, and it looks like there's a few more required things because we don't have the submit for review button, so let's see what else we need. Now you'll notice here for the Google Chrome Store, it's asking us to justify these broad range of permissions that we're asking for. And so now I'm going to try and make up some justifications. I'll fast forward through this also. Notice here at the bottom, it's asking if I'm using any remote code. This is supposed to be anything that's accessing code, maybe in a CDN or something not local to the file. I don't have any of that. That should help get it published. So let's save that draft. After this part as well. I have to provide a contact email. So developer dashboard home. Well, let's see how I get there. Aha. I need a contact email. I thought I had already set that, so there you go. Let me save that. There we go. All right, well, I just had to refresh the page. I had already set that email address that it was complaining about. I refreshed the page. Now I can submit for review. Let's go to items. Let's try that again. All right, pending review. Excellent. Okay, it says it could take up to a few business days. In my experience, it takes under 24 hours, but we'll see. Let's jump over now to the Firefox. And sure, I'll agree to the world. Oh, I thought it was a mailbox. All right, continuing on. On this site, so we're going to use Mozilla to distribute our add-on / extension. I'm going to select the same file here, prettykitty011.zip, and we'll continue on. Let's see, do you need to submit source code? I'm going to say no, I don't need to submit source code. Let's see if they reject that. But there are some cases where you do need to submit source code, like code generators and minifiers, tools that combine multiple files. I kept everything very vanilla. Okay, version is submitted. The listing will be more successful adding a detailed description. Okay, so it wants some screenshots. Let me go back and add a screenshot. All right, so not too bad. Had a little bit of a snafu with the Google Chrome store. It was easier on the Firefox Add-ons Store. And I will come back to this video once I have a result of whether or not it is publicly available on the stores. Okay, last bit of housekeeping here as we wind up the talk. I have here the Google Chrome Web Store, and the Pretty Kitty browser extension is still pending review. This is after a few hours have passed since I submitted it. But over here in the Mozilla Add-ons Store, I can see that Pretty Kitty has now been approved and it's now publicly available. It only took a couple of hours. This is the GitHub repo, and I'm going to update the README file with the results of trying to get the browser extension published into the Google Chrome Web Store. So I hope this experience has showed you that it's very easy. This basically sailed through for Firefox. It's very easy to get a browser extension listed on the public store. It gives it an air of legitimacy, even though it's requesting all kinds of unnecessary permissions, and it really doesn't need those in this case. I'm just showing cat gifs. So last bit of housekeeping here. This is a link to that GitHub repository in case you're interested in tracking the status of the Google Chrome Web Store, or in case you're interested in looking at the code yourself. I hope you've enjoyed this dive into the world of browser extensions. I hope that it's given you something to think about in terms of how readily you will go and install browser extensions in your browser. And happy hacking!